Welcome to support activity 15A, probability expected value of one categorical variable. Please read the introduction of the activity, then we start to answer the question. 1. A calendar year can be defined in quarters as shown in the table below. Let's assume birth rates are the same across all quarters and that quarters are equally long. Fill in the probability table below. As you see, the table here has basically that quarter 1, 2, 3, and 4, and the chance being born in this quarter. And since that there is equally chance the player will be born in one of these quarters, so the chance will be about 0.25 or 1 out of 4. So put 0.25 in each quarter. Number 2, researcher collected a random sample of 1,703 Italian soccer players who played in youth league and then went to play professional soccer. Making the same assumption as before, equal birth rates across quarters. How many of these soccer players would we expect to have birth dates in each quarter? Fill in the table below and show all the calculations. So as you see, is basically the table here is looking for the expected number of soccer players born this quarter. We randomly selected 1,703 players, and we know that at each quarter the chance for a player to be born is 0.25. So the easiest way is to multiply that probability times the sample size to get the expected number. So the probability 0.25 multiplied by 1703, the answer will be 425.75. To interpret the number is basic. If we randomly selected 1,703 soccer players from the population of professional Italian players and assume birth rates are the same across all quarters, we would expect to have about 425.75 quarter 1 birth dates per group. We go forward for part C with the expected number the same or different between quarters. Explain why. Obviously it's the same, yes, and this is occurred because the probability of any player being born in any one of the 4 quarters is the same. If we go for number 3, in reality birth rates are not the same between quarters of the year. Some quarters are longer, which have more days, and different cultures have different preferences for time of birth. Researchers measure the birth rates in Italy in the year in which soccer players were born and found the following results. So the results mentioned that in quarter 1, the chance or the proportion of births in Italy was about 22.48%. In quarter 2 was 24.98%. In quarter 3, 25.74%. Quarter 4, 26.80%. So part A, among a random sample of Italian, which quarter would you expect to have the highest number of players? And also, which quarter would you expect to have the lowest number of players and why? If we look back here and we look for the proportion, and you see that basic that at the end of the year there is a higher chance the player to be born than the beginning of the year. So basic, that's what we expect, that quarter 4 have the highest frequency of players and quarter 1 have the lowest frequency of players. This is because the birth rates in all of the Italy were relatively higher in quarter 4 and relatively lower in quarter 1. And a true random sample would be expected to reflect this difference in birth rate. Part B, imagine researchers selected a random sample of 8 Italian. Among them, there were more quarter 1 birthdays than quarter 4 birthdays. Is this possible? Is likely? Why and why not? So this is possible and somewhat likely, since the difference in birth rate between quarter 4 and 1 is only several percentage points. So by chance alone, it is plausible that to find more quarter 1 birth dates, especially when the sample is only 8 people. So 8 people is basically that there is high chance that could happen. But for part C, imagine the researcher selected a random sample of 800,000 Italian. Among them, there were more quarter 1 birthdays than quarter 4 birthdays. Is this possible? It is likely. Why or why not? So this is possible, but not likely. The sampling here has large number of people, and it is more likely that our sample will reflect the birth rate proportion we see in the entire population. For number 4, let's turn back our problem and remember that researchers collected data on 1,703 Italian soccer players. Part A. Use the true birth rates in Italy to find the expected counts for each quarter, assuming the player birth dates are distributed similarly to the birth dates of the original Italian population. So when we go for the table here, we are actually matching that birth date and the entire population, and we know that the proportion for each quarter, and we know we have 1,703 sample size, so we can get the expected number of soccer players born at this quarter by using the proportion and multiply by 1,703, and we do same thing for each quarter. So I take basic that proportion of quarter 1, then multiply by 1,703 and get this number, then take proportion of quarter 2, multiply by 1,703, and I'll do the same for quarter 3 and quarter 4. And as you see, we get the expected number for quarter 1, which is going to be 382.83. The expected number for quarter 2, which is 425.41, and the same for that quarter 3 and quarter 4. So part B, what trend do you notice of these expected counts? How do they shift from the beginning of the year to the end? As you see that there is basic that expected counts tend to increase from earlier in the year to later in the year. Part C, the observed birth date of the actual sample of 1,703 professional Italian soccer players are displayed below. And what happened in basic that out of 1,703 we find out that 507 that born in quarter 1, 534 born in quarter 2, 389 born in quarter 3, 273 born in quarter 4. So this is the observed number of soccer players. Do these observed birth dates have different pattern than the expected birth dates? If so, describe the difference. I see actually there is a difference pattern. Yes. So we see higher frequency birth dates in the first half of the year, with a fairly steep decline in the later quarters of the year. So this is different than the expected counts, which tend to increase later in the year. So if we compare this table to the previous table, that pattern here is almost the opposite. Part D, do we believe the difference between the observed and expected counts occur by chance alone? Or do you believe that Italian professional soccer players tend to truly have different pattern in their birth date distribution than the general population and why? So the difference here is so large, yes it is, and it's basic that hard to believe this occurred by chance. So you're actually that may have an explanation for why that happened, and your answer could be different from basic one to the another. So I will give you maybe that chance to put your explanation and answer this question. So at here we end this activity, and goodbye.